Get started, if we can. So we have a little bit of finish up from Tuesday's lecture, and then we'll get into a brief introduction on geoprocessing. In terms of housekeeping, I don't have anything to bring up today. Anybody have any questions? Points they want to raise? Issues with lab, issues with forums, blah, blah, blah. Personal problems, I'm not really that in right now. Nothing? All right, moving along. So, Tuesday's plan, we got up to talking through satellite imagery. And so I want to talk briefly about a couple of other sources of imagery that are more and more common. We've got airborne imagery and then oblique imagery, and how we use those. And then we'll talk a little bit about data sources as well to wrap up what we were covering on Tuesday. So you've all seen aerial photography. You've all worked with it now in your labs, bringing in things like Bing imagery or bringing in some of the NAPE imagery on the regular imagery base layers. How many of you have gone and downloaded aerial photography or aerial imagery from other places as opposed to just using those base maps? A few of you. Where have you gotten those from? Landsat. Okay. So Landsat's is aerial imagery, but not from a fixed wing aircraft or something else. So that would be satellite imagery. Where else? USGS. What did they have? Oh, Utah GIS portal. Okay. Which has, yeah. Yeah, so Utah GIS portal has a bunch of imagery. There's both NAPE that was mentioned, which is flown. There's a schedule out there. I don't know exactly what it is, but I believe we just had another flight in Utah last year. It seems like it's every 3 to 5 years for most locations. And then there tends to be higher resolution imagery. Also on Utah GIS portal, the whole state was flown at 1 foot resolution in 2006. And that's quite a good data set. So there's different platforms on which we can get this aerial imagery that is collected within the Earth's atmosphere as opposed to satellites in orbit around the Earth. And so the more traditional sort of platforms are a fixed wing aircraft, some sort of larger Cessna typically. And you can see why it has to be larger here with some of these camera housings and the power supplies and the computers that they need to run this stuff. It's pretty heavy payload, and there's not much additional room in some of these places. Here's an alternative platform on a helicopter. And this has a little shock absorbing platform here, and these things are just shooting away. And we talked about on Tuesday the different sorts of active and passive sensors. And those active and passive sensors can be mounted on something like this, or they can also be mounted on things like a satellite. Then there's poor man's aerial photography, and there's a number of different platforms. This is an example of what's called a helikite. It's basically a blimp. You just fill it up with helium. It's about, they come in different sizes. The ones shown here are about 1.5 or 1.6 cubic meters in volume. And you can basically just put a little camera on the bottom of these and take pictures. If you have a bunch of targets on the ground, you can georeference those targets, and you guys will do just this in our last lab for this class. So we'll go out and we'll fly the blimp on the quad, and we'll collect our own imagery. One of the nice things about these really cheap platforms is that you can get out to sites pretty quickly if something has happened. So here's an example of a tiny little reach in which a flood barreled through. And so it takes time and particularly a lot of money to mobilize a fixed wing flight. How much does it cost for a typical fixed wing flight? What's that? $10,000. What were you going to say? So, what's that?
I think when you do like a county flight, it's a spectral imagery, it's like a couple million.
Yeah, so it depends on what we're asking for. Just to rent an aircraft, hire somebody, isn't necessarily all that expensive. So on the order of hundreds to maybe upper hundreds of an hour, right? But to get processed imagery back, just straight RGB imagery, that 10,000 number is a pretty good ballpark for just minimum sort of mobilization costs, minimum processing, et cetera. Whereas these, you have to pay for a canister of helium, and once you have the blimp, these things are, a couple grand sort of thing, and it's just a regular camera, a little point-and-click camera. So there's, these things aren't really economical, some of these other platforms at larger scales, but for smaller scales, they make a lot of sense. People have used weather balloons. Difference between sort of these weather balloons or other sort of blimp-like platforms and say this is called a helikite just because it has this wing on it, and it's actually pretty difficult to control something just like this and actually navigate where you want to be. And so having that little bit of resistance against some wind there actually makes it a lot easier to track and control these things. There's also helicopters. There's a few of these down at the water lab. There's actually a class you can take. It's listed on our other classes, like follow-up classes, things where the whole class is about basically building sensors for these platforms, and they go out and fly and crash these things. So these are just toys at one level, but you can use them to collect really good data. Also, poles are actually used more than you might think. One of the annoying things about poles is the imagery always has a pole in it. One of the annoying things about these tethered solutions is they always have a string in it, but that's a little bit more subtle. But it depends on what you're doing. Some of these things can be quite useful. Then there's drones or UAVs, unmanned aerial vehicles, and so not just for the military anymore. Actually down at the water lab, Aggie Air, Austin Jensen and folks down there have actually developed this platform. On the one hand, it's really high-tech and really neat. On the other hand, it's a glorified piece of styrofoam with some cutouts in it, a little basically toy remote control unit, and then they've got a computer on board as well as that stores all the images. And they've got 2 cameras so that they can get both RGB, which means what? Red, green, blue, so standard imagery, as well as near infrared. And so I'll just show you how this thing takes off, and you can go to aggieair.usu.edu and check out some of this other stuff. But here we go. This is their takeoff. I should have plugged in the sound, but I doubt it'll work anyway. So what he's got there, you can't really see it, but he's put a stake in the ground and he's walking backwards because he's got a bungee cord. And he just tilts this thing up in a second. And he fires up the little motor and lets it go. And then once it gets into the air, it's actually being controlled by, they've got radio communication with a laptop, and it's actually being controlled by a flight plan that keeps track of exactly where it is, tells the plane where to go, and then they've got a manual remote control they can take over if they need to. And so you can get imagery. There's a whole bunch of different platforms like this now that different folks are using. Let's see, I gotta find this. And so one of the things I want you to take away is that if you want aerial imagery, there's a lot of different ways to get it. And the choice of platform is a combination of cost and what's appropriate for your needs. And so your needs are going to be defined by what is the resolution of imagery that I need. Because if I'm talking about a helicopter, I have a lot different sort of options than I do with, say, a fixed-wing aircraft in terms of flying height. Also, these things, I cannot fly these things generally above for sort of 500 meters, at least legally. On the blimps, they have about a 300-meter tether. If you're dealing with a pole, it's obviously only going to be able to go up as high as the pole could support, right, which is probably not going to be much more than 20, 25 meters. So all of those things are going to translate to different extents of your imagery and different resolution. Okay? Are there any questions on that stuff? We may have Austin come in and give a guest lecture. He often does. It might be in the latter 5 weeks, but everybody's welcome to come and see that. So, and we talked a bunch about aerial imagery, but it's worth mentioning oblique imagery as well. Oblique imagery can be very useful, especially with sort of the advent of geotagged images. And so a lot of you, well, I don't know, who's worked with a geotagged image and knows what I'm talking about? Nobody? So what is a geotagged image?
It's an image that has a geographic location.
Right. Right. So it just has a tag associated with the actual image file that is just giving you the coordinates of where that image was taken, and sometimes the orientation which the camera was directed. Not always. And so if you put these into things like Picasa, these online web albums, they'll have an option for things to be geotagged, and it'll basically show you where your images are on a map. And so this is becoming more and more common. We can also have shapefiles that have images associated with them where the image is an attribute. It's actually the location of the image. And so you could have a shapefile that's just a bunch of points. The points are the geotagged photo locations, and every row in your shapefile would be a different image, for example. And so that's worth mentioning. Another reason for mentioning the oblique images, we'll talk later in the semester about an emerging technology called structure from motion. But you can actually just take a whole bunch of photographs, and as long as they overlap, they can be as oblique as you want. As long as they have good overlap in them, you can actually build three-dimensional point clouds from these without hardly any effort. It's really, really simple. So that 3D point cloud is just a fancy way of saying a whole bunch of XYZ points. And there's a lot of spatial analyses you can do with that data if you georeference it. So we'll talk about some of that later in the semester. I just wanted to mention it now. So is this an oblique or a georeferenced image?
Could it be both?
Could be.
So it is oblique. It's definitely oblique.
It's definitely oblique because,
Well, you're at an angle, you're not looking straight down.
right, but even, so what's it called when we're looking straight down? What's imagery called? Nadir, yeah.
What is it called?
Nadir, N-A-D-I-R,
Oh, okay.
right? So it's actually, I mean, it's actually pretty much almost virtually, even if you do have the camera pointing straight down, it's only going to be the central portion of your image that's going to be perfectly nadir. And so with this one, this probably is an oblique image, or it could be the outskirts of another image. But you will get, particularly with skyscrapers like this, you will see that there are portions of the photograph where you may see all four corners of the top of the building, but you're not going to see all four corners at the bottom of the building. And so there's a distinction when we talk about aerial imagery that we are going to use in GIS, not georeferenced, not geotagged imagery, but georeferenced imagery, like the base map layers that we use. There's a distinction between orthorectification and georectification. And without reading those definitions, has anybody come across this distinction already? Or have firsthand experience with this? It's okay if not. All right, so what we're going to do later in the semester is georeference some images that come out of a blimp. So that it's just going to come from a camera, and those images aren't smart images, but we're going to see in those images control points, targets that we know the coordinates of, and then we can stretch that image to be a good base map layer. And so that's a process known as rubber sheeting, and there's a bunch of different methods for doing that. And it's analogous to what we did with our point data in Lab 2, but it's for raster imagery. Orthorectification is a more sophisticated method of doing the same thing. Orthorectification actually looks at the vertical values. You have to have an elevation model as well. And then as part of the processing, it's deriving another independent elevation model from that. And so you have, with orthorectification, you end up having to apply a more complicated model to warp and stretch that because you're taking into account, for example, is this pixel looking at the top of this skyscraper or down here on the sidewalk? And depending on what you're looking at, you're going to treat the stuff that's in between much differently. Okay? So georectification or georeferencing or rubber sheeting, that's the simpler method. That's what we'll do. But orthorectification gives you a more accurate and precise product. And so when you're downloading imagery from different data sets, you want to pay attention to whether it's just georeferenced or orthorectified. So the 2006 imagery that's on the Utah GIS portal, that's orthorectified imagery. So that's a really high-quality product. All right. So in terms of data sources and where you guys get this data, we can kind of lump it into data capture and data collection. And one of the interesting and frustrating things, particularly for those of you, yeah, question.
I was wondering, when you were talking about the orthorectification, where will it say on there? How will you know?
This, so on Tuesday, we're going to talk about metadata.
Okay.
And one of the themes that's going to come out of metadata is just how inconsistently people report and agencies and organizations report metadata. In a perfect world, the metadata would tell you exactly how that image was produced. In reality, it depends on where you get it, whether you actually know.
Okay.
Frustrating. It's a good question. So one of the things that's surprising in terms of under this sort of heading of, where do I get this data, whether it's through capture or collection of your own primary data or getting existing data, is just how much time is spent getting that data. So for those of you in the project class, the reason we're starting now thinking about that, and subtle reminder, after February 1st, you're supposed to have me a proposal, haha. But it takes forever to just get what you want, right? Especially if you're going out and collecting it yourself. But it takes a long time just to go to these websites or even hook up to, say, some sort of web mapping service or a GIS server, get the data, and then is it in a format that's useful to you? Is it in the format you want? Then what do you have to do with it? So the actual steps of working with that data oftentimes aren't all that, that cumbersome or time-consuming, but getting it to the point where you can work with it can take an enormous amount of time. So don't underestimate that. We can break the data capture into primary and secondary data, where the primary data is stuff that we would go out and collect. So for example, the blimps. We would go out and we would fly that, versus secondary data that might have been created by somebody else and collected by, whether it was satellite imagery or someone that commissioned a flight. We would take that imagery and then we would derive other products from it. And so those other products that we derive from it would be a form of data capture. This is semantics. That's a similar subtlety to the same thing. I'm actually going to gloss over this. It's not that important. In terms of you making primary data, other than going out in the field and collecting it, there's other ways you can do this. Digitizing. Anybody digitized before on an old digitizing tablet, or just off of something that you brought in?
We use this little tablet with the mousey thing.
Mm-hmm. With the mousey thing. So everybody know what a tablet is? It's just instead of you having a mouse pad that just tracks position based off of where the laser or where the ball goes, you actually have a tablet that has defined distances on it, and so it's just where you move across that surface or that tablet. So tablets can be something that are this big. They can be something as big as the screen here. And so a lot of times, some of those old large format digitizer tablets, you would take an old hard copy map and you would tape it onto it, and then you would tell it what the bounding coordinates are. and then you would literally trace, right? And now you do this, no one actually uses these hardly anymore. Instead, what people do are use large format scanners. And so you go and you scan that big paper map, for example, and then you bring it in, you georeference it, you rubber sheet it, and then you trace, okay? And so what kind of data am I getting from, say, a digitizer? Is it going to be raster data or vector data? Vector. So, because I could be tracing points, polylines, or polygons, for example. We can scan in some of those same sources, old maps, old aerial photographs, etc. And when we scan those in and we georeference them, we're obviously getting raster data. So we can also get data where we're converting it from other digital sources, for example, film. There are actually data sets out there where there was just videography collected, say from a flight, and so you might be taking stills out of that. What else? You can obviously get information from a GPS or from other surveying methods that we're going to talk about later this semester. So there's some sites on here. You don't have to write these down. They're referenced on your website. These are some common things that you may come across in terms of distribution centers. USDA's Geospatial Data Gateway is one that we'll probably use later this semester. And then we've got things like the Aeros Data Center. How many of you have used this one from the USGS? A couple of you? What do you think of it? Very frustrating. Super cumbersome, hard to find the data in the format you want, hard to search. The data you download, you end up often having to convert into something else. Unfortunately, though, there's a lot of great data on there. So that's one place. Here's an example of some of the products that they have up there. What else? Related to that, as part of that, they've got this seamless data distribution system, which is this really nice idea. And so there's a distinction between places that host imagery and serve it in a seamless format versus host it in, say, tiled or organized formats. So seamless is basically you draw a box on the map of the area that you're interested in, and then it will spit out the data sets that you want for that area, versus having to go and have that classic problem of our study site spans 4 images, right? We're right on the corner of a whole bunch of images, and you have to go and download all those images. Or your site might span 2 political boundaries, and the data is available for county by county, for example, and you have to download both of those. So this is a very poor example of a web GIS. This is actually an old picture. They have updated this a little bit, but it's still pretty klutzy. But this is one way in which some of these things are distributed. The Utah GIS portal, you should feel lucky that you're in Utah, at least for this reason, because there is actually a lot more information from this statewide repository than you have at most other states. And the reason is pork. Basically, they got this earmark a while back, and they poured a ton of money into organizing this data, actually commissioning flights and getting additional data, and it's a really great resource. You move to another state, and most other states don't have anywhere near this, this comprehensive of a GIS portal.
Like big government, Joe.
That is big government, but so big government might be bad or might be good depending on your perspective, but in this particular class, you might appreciate that pork for whatever reason. So, Utah GIS portal has a whole bunch of different ways in which these things are served, and so you can go through and you can browse and navigate on static maps and download particular tiles. You can go in and navigate on more interactive maps. You can just go into an FTP listing, a server, and just grab files off. Or you can actually load in a reference in ARC to what's called a ARC server, and you can then just load up data layers right out of that server. So it's sort of like a web mapping service we talked about earlier. All right. So digital raster graphics, things like the USGS base maps, this used to be a big issue. Esri's kind of making it a non-issue for you now, because now you can go to that USA topo maps at the bottom, and you get these USGS quads in a seamless format. In Lab 3, I'm giving you a USGS quad base map as a background layer, and it's actually a data layer that you have to work with. But getting that data is a little bit confusing, whether or not you want this in, we talked about these examples of USGS quad maps, whether or not they're raster or vector. So what are you using, those of you that are in Tuesday's lab, for a USGS base map in this week's lab? Is it a raster or a vector? It's a raster. And so if you want vector data, you can get those. They tend to call these digital raster graphics. The vector data, the individual layers that make up that map, are often referred to by the USGS as these digital line graphs. It's just the vector data. You can go and get those data sets as well. And then USGS often refers to aerial imagery. It tends to be older imagery now because it's been superseded by other products. But these digital orthophoto quads, you can download. And those orthophoto quads, when it says ortho, ortho means that it was ortho-rectified as opposed to just geo-rectified or geo-referenced. Okay, so any questions on any of that?
Where's the best place to get quads?
Best place to get quads?
Yeah.
For where?
What?
For where?
Is there not a good national?
Well, yeah, so I should say the USGS, but as we mentioned before, the USGS website's a pain. The USDA Geospatial Data Gateway, which is linked off of there, is a good, that's a much easier website to use to get those if you actually want the data sets. But remember, if you want those USGS quads, they are just a base map on Esri now too. So if you're doing something I mean, how many of you have found the base maps don't always export perfectly, right? So I can't explain exactly why that is, but because they don't always export perfectly might be the reason you want to download some of the raw data. So USDA Geospatial Data Gateway is a good place for the states. You can also get all the quads for Utah on the Utah GIS portal. So it depends on where you're working. Other questions? Okay. So you all should have read the help topics, did you, honestly? Yeah? Good. I don't know if I believe you. So we're going to talk about geoprocessing. Geoprocessing is something that hopefully, was this introduced in 1800 for the undergraduates? A little bit? No? Okay. Geoprocessing is not a GIS term so much as an Esri term. It's a term that Esri coined to refer to basically anything that allows you to automate GIS tasks and perform spatial analysis and modeling. So after next week, we're going to switch gears out of this sort of background catch-up stuff, and the 6915 people will say farewell, and we're going to focus much more on this spatial analysis and modeling. And almost all of that is going to be using geoprocessing. But it would be a crime for us not to at least, the people that are taking 6915, at least make you aware of geoprocessing. All of you have used it, whether you realize it or not. And there's probably a lot more functionality that you may be unaware of that's worth highlighting because it can be a huge time saver. And so one of the things that's useful here in this sort of description of what geoprocessing is the fact that almost all uses of GIS involve the repetition of work, right? And so what's wrong with repetition?
Boring.
Boring. So when I repeat myself in class, it's boring, but hopefully useful because it pounds a concept into your head. But yes, it is boring. What else is wrong with repetition?
The more times you do it, the more chance of error you have.
Exactly. So mistakes can easily be made when you're doing something over and over and over again. And so repetition, if you can automate some of that work, it helps you avoid those potential blunders and mistakes. What else? There's a real obvious one, yeah.
Takes a lot of time.
Yeah, that's exactly it. It just takes a lot of time. So if we can streamline any of those processes, that's very useful. What you'll find in this class are there are a bunch of things that we end up doing that are explained in a much more verbose fashion or walk you through a whole bunch of steps. And part of the reasons for that is so that you understand all those little nuts and bolts and all those little pieces that went into that. So you're not just pressing a button and voila, you get an answer and you have no idea how you got it. Almost everything in the video tutorials, everything in GIS, there's very few things where there's only one way to do it. Most things, there's a lot of different ways to do it. And so what we want to be a little bit more aware of, what is the sort of suite of geoprocessing tools that we have at our disposal in at least ArcGIS, and then how can you guys use them? So the types of geoprocessing things we've got, as was mentioned in those help topics, we've got tools, we've got models, we've got scripts. Where do you guys find those three things? Arc Toolbox, that's one place in which they're housed. Where else? Geoprocessing, yeah, and the catalog, Arc Catalog, and you can search for these things too. And then add-ins, so the Lab 2 used an add-in, the Champ Transformation Tool. Was it difficult to install the add-in? Double click, it's there, right? Now, have any of you installed plugins yet? Yeah? And what's that basically entail? Or were you falling asleep? No. You haven't installed a plugin, or you have? No? Okay, sorry. Won't pick on you. Plugins, anybody? So plugins, you have to also shut down Arc, and then you double-click on something, and it's like installing any other piece of software, and there's usually a wizard that walks you through the installation. The big difference between add-ins and plugins is that add-ins don't require access to your Windows system registry. And so they're not putting stuff in the background that requires interacting with Windows nonsense registry, whereas plugins do. There are some advantages to that because you can control where default locations are that things are stored, for example. So there are reasons people build plugins as opposed to add-ins as well. And so some of these things, when you do add-ins and plugins, they get added as toolbars, and then you found that there's a whole bunch of other toolbars in ArcGIS as well. Some of them are associated with certain extensions, and some of them are built in to ArcGIS. So are the tools and the toolbars the same thing? No? Yes? No? Not really. So what's the big distinction between something you access from a toolbar versus something you access from a tool?
Not all the tools that are in that you have access to are on the toolbar. You can access them through other parts. You can search for them, but they're not all just sitting there on your toolbar.
Right.
So, like the interactive part. Right.
You're right, and we're gonna dig down a little bit deeper into some of these distinctions. So you guys already know about Arc Catalog. If you go down to the bottom of Arc Catalog, there'll be a thing called toolboxes you can expand out. And that's the exact same list that you have in your Arc toolbox, right? You guys also know about the search capabilities, so you can just type in, if you can't remember a particular tool's name or where it was stored in Arc Catalog, you can just search for it, and then it brings up this dialog. And there's a couple of things that you may not be aware of in that dialog. So let's bring up the search window. So the search window looks like this. I get to it either from this button up here, which is the search window, or I can go to Windows and search and bring it up, or hit Control F. What's some tool someone's used? Clip. All right. So if I do a search for clip, I get this list. Now there's a distinction between these three things that are here. So if this top one, if I hover it over it, it gives me a little preview of what that tool is. The middle one, by contrast, it gives me a hyperlink. If I click on the hyperlink, it should go to help or the item description. Oh, that's actually pretty useless. It's supposed to go to help, I thought. This one should take me to catalog and to the location of it. This is always the good thing.
There in the yellow box.
What's that?
Isn't that sort of the description in the yellow box there that you had?
The yellow box, which yellow box?
That one that's popping up when you hover over the site.
It is, but it's what I'm trying to show you and failing miserably at is that what each of these three things, what's supposed to happen is the one takes you to the tool, the other one takes you to the help, and the other one takes you to its location in the toolbox. And so I'm going to just try a different one here and see if that works instead. Okay. So that one, for whatever reason, does seem to be working. So that one's taken me to the location in the toolbox. Whereas if I'm back in that search and I hit this one, that one should bring up the actual tool itself. And so this could be part of my issue. How many of you get these script errors? Sometimes. They're fun. This is usually the best way out. Well.
At least it told you there was a problem instead of just...
Yeah, and it depends on the mood, right? You know, sometimes it feels like telling you what the problem is, and other times it doesn't. But what's supposed to happen is the green up top gives you the link to the tool, the middle one gives you the link to the help, and the bottom one takes you to where it is in the toolbox, okay? And so there's these different ways that you access the tool itself, whether it's through the search window, whether it's through the toolbox, and then you bring up the actual tool, and all tools have these input parameters, right? And actually, while I'm blabbing away here, I'm going to actually start up ARC again, because that will be a slow process. And then we'll be able to go back to it in a minute here. Okay. So we have to enter in parameters to run the tool, and then we hit OK to actually execute the tool, right? So that's geoprocessing. Now when a tool runs, there's a couple of things going on that you may or may not have noticed. One is that there's usually some sort of status bar down at the bottom of ArcMap that's telling you the progress in executing that tool. Another useful status bar that Esri seems to use a lot is the ever-famous not responding thing that happens at the top of your dialog. And so when you see those not responding things, if it hasn't been responding for 2 or 3 minutes, that's cause for concern. When you first see it, if you start hitting other buttons, that's a guaranteed way to crash ArcMap, and half the time that not responding thing is actually not actually a problem. You can just kind of let it pass. So be a little bit patient with these things. What happens after the tool is run successfully is a little pop-up dialog comes up at the bottom of the screen here. And if it's worked successfully, you have this little green check mark next to the tool. Have any of you run a tool and then checked, actually clicked on that little box there? Yeah, what happens?
It brought up like a step-by-step thing of what the tool did.
Yeah.
I clicked on it because it wasn't working.
Right, so when it doesn't work, instead of the blue, or I mean, the green check mark, you get the red X, right? And so if you, in either case, you can click on that and it takes you to what's called a results window. So let's actually see if ARC is loaded here, and I can bring in something. Let's see here. Come on, you can do it. And so if I was to, let's say, what do I want to do? I'll make a hillshade of a DEM. So here's a tool. I come into the tool. It's got certain parameters. There's this show help and this hide help screen. And the help screens, gosh, this is nice. Get this where you guys can actually see it. The help screen, when you first come up, it gives you a little indication of what the overall tool is, and then as you click on different inputs, it's usually telling you what those inputs are. So the help thing's quite helpful. The other thing that's in here is the environments tab, and this takes you into environment settings. And so environment settings is where you can control, for example, some of the things that we were talking about on Tuesday with regards to controlling the extents of a raster, the cell size of a raster, for example. So I would, for those, I might go down to raster analysis and processing extents. And so here I could do as specified below, and I could actually type in the extents that I want to use, or I could take them from another layer. Similarly, down here, I can specify my cell size, and there's all these different environment settings. And what you'll find that's really confusing about these environment settings is that there's actually 4 levels of them. And so what we're looking at here are the environment settings associated with the tool, and I'll come back to that in a minute. So when you change those environment settings, it's going to control how the tool then implements whatever you're asking it to do. And so in this case, let me just find a raster that I can make a hillshade from. So that'll work. Okay, so this little red X here, that's telling me that it can't do what? It can't output this raster because it says this is an invalid output where it was trying to put that. So what that means, I can make that go away if I give it a particular location. So I'm just going to call this HS example. And that's a other issue. And so now if I run this tool, let's look at what happens down here in the bottom of ARC. See, it's giving me this progress on running the tool, and now it's run it, and I can click on that. It brings up this results window. What's the other way I can get to that results window? I go to Geoprocessing and Results. Okay? And now inside here, this is the tool that was just run, and it's giving me when it was run. And then the first thing in here is the output that it created. And I can right-click on that and re-add it to the display or find out where it is. It's showing me all the inputs that I used for that tool. And it's showing me all the environment settings that I had. And it's giving me messages. Now, these messages sometimes are useful, sometimes are a little bit more cryptic. But those messages are really, really helpful for troubleshooting when things went wrong. You can go into those messages, and you can drill down and figure out what went wrong. Another really handy thing about the results window, so repetition, right? I run this, it crashes. What do? I go back into ARC Catalog, I go to Hillshade, and I enter in all that same stuff again. I could get that wrong. I can double click on this and in the results window, and it brings up the exact same parameters that I used before. So that's really quite useful. So I was back in the results dialog here, and I double-clicked on the actual tool itself, and it brings up those parameters. And so I can rerun it exactly the same, or I can run it with something slightly different. So maybe I change I change my z factor, or I change one of my parameters and see if I can't get it to work. Okay, so that's a really, really useful aspect of the results window. The other thing we can do, if I run this hillshade again, let's do something funky. Let's change this, and then I'll do this as hillshade example 2. And while this is running, see the results. Well, it went a little quick there, but while it's running, you actually see a little clock of this. And you can watch it as it's going through its steps internally, and you can figure out where it's crashing. And that can be really helpful for, instead of just saying, oh, it didn't work, you're posting a thread on the forum, and I ran this and it doesn't work. It's hard for people to help you when you just say it doesn't work. But if you can give them some specifics about where it crashed, how it crashed, etc., people are in a much better position to potentially help you. Okay? So what else is worth mentioning here? In Arc Toolbox, let's say that I have 10 DEMs and I want to run a hillshade on all of them. That's a pretty damn repetitious task, right? Going through. Yeah, I could use the results window and go in, and then I don't have to change all the parameters, just a couple. But one thing that's real easy to do with any tool in the toolbox is to right-click on it and then hit Batch. And all batch does is it brings up a table, and the table has columns, and the columns refer to the inputs for that tool, and then the rows for the number of times that I want to use it. So for this one, it's asking again for an input and an output raster, and then these parameters of the tool, right? And so what I can do is I can double click on any of these parameters, and I could go in. This doesn't make any sense what I'm doing right now, but just to illustrate. And then I can add another example, and I could do this one from a different raster. And I can even do things like I can copy the text that's in these upper things, and I can paste them down below and then edit them. And so I can build this little table out. And then I just hit run, and then it runs through every single task that you spelt out in it. So that can save you a bunch of time as well. Okay? Are questions on these things? Yes?
Was that just going to run a hillshade, or could you run other tools from that multi-tool function?
You can go to any tool here.
The same one.
What's that?
So say you only want one hillshade, but you wanted to do a clip and something else. You run multiple tools off that.
I'm going to show you in a second what the solution for that is. Yep.
Okay.
Yeah. So no, so the batch processing is useful for if you want to do the same task where it's just one thing over and over and over and over again. Okay. Sometimes you want it to be a little smarter, and you could write a script that, for example, said, well, load the folder that all my DEMs are in, and then do the same thing on everything in that folder, as opposed to you having to do it. And that's real easy to do, actually. But that's a little more advanced. So one of the other things that, let me catch up to where we are here. So the environment settings. I mentioned those environment settings. And what were those again? We're going to talk more about them later when we get more heavily into spatial analyses. But where did I get to environment settings again? Did anybody remember? So I was in a tool, and I went to environments. And then I had all these environment settings. So things like workspace, the output coordinate system that I want to use, and you can see the defaults, same as the input, for example, here. I have a whole bunch of things that I can go in and control how that works. Now that same list of environment settings exist at 4 different levels. And this is really confusing, and they compete with each other. What Esri Help says is that there's this application level, tool level, and model process level. So what I've shown you there is at the tool level. The application level are the defaults for ArcGIS. And so if you want to change the application level environment settings, you go into Customize. And I might forget this. Where is it? I'd actually have to search around a little bit for this. I thought it was in ArcMap Options.
It's under Geoprocessing.
Up. Thank you. Those environment settings are for the application, versus the ones I access from the tool are from the tool. And according to this list, the tool is supposed to override the application. It doesn't always work that way, but that's what it's supposed to do. So, and then there's these model level and model process levels, and I'll get into those in a second. So let's talk about Model Builder, which answers your question of how do I combine a bunch of different tools into one. There's a lot of ways to do that, but ARC's made a very simple format, or a simple way of doing this. So here's an example where I have some inputs. These inputs are these blue layers. And so one is a polygon that's study area, and the other one is a polygon that's a soil map. And so what I want to do is I want to clip that down. So I want to clip it, the soils layer, down to my study area. And then I want to add some field to it. And then I want to do some calculation in that field. Maybe I'm recalculating areas, for example. So if I have soil types in my map, and then I clip it down, if I was to have a field that had the area of soil type, now that I've clipped it, I need to recalculate those areas, right? And so I could go in and add a field that does that, then I could calculate a value for that, and then I output this additional vector data set. So if I was to do all of that manually, I would have these two intermediate data sets, right? That I would either need to overwrite or have something that's 1, 2, 3, and then remember to go back and clean those up. Also, this is a bunch of steps. So instead, I can build a model. And these models are really, really simple to actually throw together. The details of whether or not they work is another story. But what happens here, it's probably easier just to show you some of this instead of talking about it. Let me grab ARC again. So how do I get a model? I go into, let's say, ARC Toolbox. And in ARC Toolbox, you've got a bunch of standard tools that are installed, and then you can always right-click on the ARC Toolbox, and you can add a toolbox that someone else has provided, for example. So you could add in some other tools that people have made. You can also, when you have added in, say, for example, your own toolbox, inside of that, you can make new tool sets and models, right? So in here, if I want to make a model, I just go to New and Model. And there's tutorials on all of this stuff, so you don't need to be frantically writing this down. I just want you to be aware of this. So I go into Model, and I have what's called a canvas here. And so how do I work with this? Well, why don't I drag in a data set? So I could drag in a data set, and I just drag it onto my canvas. And why don't I grab a tool that I would want to use? And so let's see, what was I doing before? This doesn't make any sense because I'm going to run a hillshade on a hillshade, which is stupid, but we'll do it anyway. So I can drag in a tool, right? And so now I've got this hillshade tool. And if, let's say, if I could drag in other layers here that I would want to have, but let's just keep this real simple. So right now, this is blue as opposed to white, which is telling me that this, if I go to the properties of it, oh, actually, it's not the properties. What is it? I have to open it. This is referring to a specific layer that exists. Okay, so I've got this one is blue. These ones aren't hooked up yet. And so what I have to do is I have to make a connection between an input and the tool. And so when I let go of the mouse there, it asks me, well, what am I giving the tool? Am I giving it its input, or am I giving it some environment setting or a precondition? In this case, it's the input raster, and then those things become colored, which is telling me that they're bolted together now, and this thing can run. So this is a pretty boring model because it's just doing one simple task as opposed to bolting together multiple tasks. But you simply keep dragging things on here, and you can take your tools, and this particular tool is only ever going to run on this data set. So that's not all that useful, right? Because it only can have that as an input. What you can do is you can click on one of these and you can turn it into what's called a model parameter. And what that means then is instead of it being that data set, it's any data set that the user specifies when they run that model. And so I can save this model. And so here's my boring model. And this particular model only has this one input, but now because I made that a parameter, I can go and I can select whatever input I want. And then I can run this tool, and because it's also in my Arc Toolbox, I can batch this tool. I can do all sorts of different things with this tool. So yeah.
On that model, so when you get your
Yeah.
output raster, can you run another tool on that output raster? And then that
You can make these things as long-winded and as complicated as you want. And if you're intimidated by coding and like learning Python scripting or something, for example, a good way to learn about how to code in Python in ArcGIS is you can go to, so like here's another model. This one's obviously a little more complicated. It's got more options. If we wanted to look at what that model had in terms of, I'm going to just pin this, in terms of things, right? So this model's got more things going on, right? So it's got one input, but then it's got 3 parameters here. It's creating both a tinder raster, and then that thing is used to make a DEM, which then a hill shade is calculated off of that. Okay? So don't worry about whether or not you understand yet what this tool is actually doing. The idea is there's a bunch of pieces here that you can bolt together, and you can save that as a reusable tool. And that is a way of really increasing your efficiency when you're working in ArcGIS. So a general rule for these things is if you find yourself doing something more than 3 or 5 times, some repetitious task, maybe consider building a model or writing a script to help you with it. Question, Noah?
Yeah, so can you open that up as code in Python?
Yeah,
Build
that's,
that model and open it up and then make edits?
that's what I lost my train of thought there, sorry. So if I go to edit any tool, and I'm going to go to a simpler one because the code will be simpler. And I go to edit that tool, and I go to model. Let's see. Export to Python script. And I don't know, let's just dump this on the desktop. So there's a Python script. Oh, whoops. Don't want to do that. Yeah, I should have edited it. Come on. Edit. So when you install ArcGIS, it also installs Python. Python's a scripting language. And so here's a shell, which is like you can think of as a command prompt to run these things. And here's the code. And so I apologize, it's a little small here on the screen, but anything with a pound in front of it, or a hash key, is a comment. And so none of that is actually, I mean, this is just giving you some background information. The first actual command here is import ArcPy, which is basically just saying import a library of things that I can access, and this one happens to be the ArcGIS Python library. And then it says check out any licenses that you need to run this. And so this particular one is using an extension called 3D Analyst. And so it's checking out the 3D Analyst license. And then here's the actual script. And so here it just says the hillshade example. It's loading up a dialog. And then here it just has, where does it actually get down to the meat of this thing? This is the variable that's specified. It's giving a name to the variable. And then this is the actual process down here where it runs it. And so it's calling up the hillshade, and then it's giving it the parameters that are specified above and by the user. And then these other things were just built in as defaults. And so I could expose these parameters as parameters to the user. In this case, they're hard-coded. And that's all that script is. It's really, really simple. And so a good way to sort of learn how these scripts work is simply making a model and then saving a Python script from it, and you can.
Yeah, that's why I was asking.
Yeah.
It seems like an easy way to learn it.
Yeah, it is a real easy way to learn it. Way beyond, if you're in here for 6915, way beyond what you have to worry about. But these are good things to be aware of because they're actually pretty easy to teach yourself. And we'll start playing with some of these things in the advanced class as we move ahead. Questions on some of this? It's a lot of information I'm throwing at you, but I just want to get you guys sort of thinking about ways of making your life easier. Okay.
Oh, if you make a model, where does it save it? Can you save I save it to my flash drive and I can just reload that model?
That's a yes is the answer.
Don't you have to make like a toolbox to put it in or something like that?
It's a little tricky. So I've got a tutorial that sort of walks through where these things get saved, and then there's some good ones on Esri as well. When you're in here, when you make the model for the first time, this toolbox has a location, and so in this case, it's going to get saved to that particular toolbox. But these toolboxes, if I add a toolbox, you can save a toolbox anywhere you want. So for example, on a jump drive, and then you could bring that to another machine and then load that onto that so you can use it. One confusing thing about these ARC toolboxes is if you're working on the same machine and you go in and add a toolbox, the toolbox is saved in that map document. Okay? The toolbox doesn't live in the map document, but the reference to the toolbox that comes up in ARC Toolbox is part of the map document.
When you open a new map document.
It's not there. Unless you go to right-click and you save the settings instead of to a file, you save it to the default. If you save it to the default, then it will always load those toolboxes, only for that machine. So in lab, if you always want the same toolboxes to load, you should probably be using one of the more klutzy accounts that's based off of your A number, because that will save those settings. Otherwise, it's just coming up every time. So nuances that are, those are important details, actually. Okay. So we've actually talked about batch processing, and scripting is a way of just talking about programming or writing code, writing scripts that don't have to be compiled. So there are high-level languages and low-level languages when we're talking about computer languages. So spit out some examples of computer languages, programming languages. C++. What else? Java. Yeah, yes. C#. What else? R, SAS. So which of these are high level, which of these are low level? What's the difference between high level, low level?
C++ is high level, R would be low level.
What's your definition of high level and low level?
I mean, I kind of think of it as like C++ builds the building.
Uh-huh.
And R or Python would be something that, like, I don't know, electrically wires it or
Okay.
the chair or the table, something like that.
So those are really good analogies. Use those same analogies, but with low level is building the foundation. Low level is code that has to be compiled. When you compile code, it creates, either in Windows at least, an executable file, a .exe, or a library that can be accessed from other things, so usually a .dll. Those are much more complicated languages and much more complicated building blocks, whereas things like SAS, R, MATLAB, depends Java how you use it, things like Python, these are all scripting languages. And all scripting languages do is just, they have your code, and when you run them, the machine just reads through and just runs whatever you tell it to do, as opposed to compiling that into its own program or its own library. And so that script that we looked at is an example. And Python, there's a whole bunch of different languages you can use, but Esri is really taken advantage of Python as sort of a default for the simple stuff, at least. And Python is really, really easy to port into things like R, and there are some classes on campus that you can take that help you kind of build up some of these skills. And the programming itself, I mean, there's a whole lot of details, but usually, you know, what happens is this thing is getting read through in order, right? And your script line by line and doing whatever you tell it to do. And you control whether or not something is done with conditional statements like if, you know, so if some condition is met, then do whatever's in here. If not, then you skip it, or if something else, you can have an else, you do this, or you can have an else if, and you look for some other condition, right? So that just determines whether or not certain pieces of your code are actually implemented or read. And so you can think about in your tools how if a user enters a value greater than this, then do that. If it is less than this, do something else, right? And then the other big thing are loops. And what's a loop? Who's
For a bunch of different sites or points.
Yeah. So you could do it by some just for this number. So do whatever's in this block of code 10 times. Or you could say, what am I doing? I'm going through each row in a vector data set. So for every row in that vector data set, do this calculation. So what you could do is, instead of saying for 10 times, you could say for the number of data sets or rows in my feature class, do this operation. And so loops allow you to repeat things. Those are your two basic building blocks in writing code. And you know, it's just like learning some other foreign language, right? Learning the first one is a real pain, and then after that, you can look at other things and you can pick it up. You see patterns pretty quickly. It's not that difficult. Even if this seems really, really intimidating at first, when you get down to it, this stuff is actually very simple. Okay. And the Python scripting, we already mentioned how you can cheat and right-click on, or go into your model, for example, and export out some script to see how that stuff's written. And these things obviously help you with your efficiency in going through and doing tasks. So what I'm going to encourage you guys to do as we're moving forward in the class is when I start asking you to do more repetitious tasks, I may not tell you, go write a model or go batch process or whatever, but you know that this is in your back pocket, something that you can work with. And I'll point you to some resources. There's already some on the topic page for this week. But in particular labs, I'll point you to some specific places to get some help on some of these things. And ask questions in lab, of course. Okay. Other questions on any of this? Geoprocessing stuff. So in a nutshell, what's geoprocessing? Working with the data, the models. What else? What?
Allows you to perform spatial analysis.
Allows you to perform spatial analysis. Someone else? Pardon?
And automate it.
Yeah, there's ways of automating it. So it's this whole suite of things that help you do the tasks that you do and help you speed up repetitive tasks. And so things like that results window are really useful to keep in the back of your mind. When you're accessing tools from a toolbar, in general, if they're ARC tools, nothing shows up in that results window. But if they're a tool that somebody else made, so you might download somebody else's toolbar, and it has some fancy command on it, you can, if you open up that results window while the command's running, sometimes if they've done that by bolting together actual Esri commands in the background, you're seeing the geoprocessing results being reported as it's going there. And so not all tools do that, but the ones that do, that's a helpful troubleshooting step. This week, you're producing a geologic map. How's that going for people on Tuesday? Okay. A little tedious, but okay. The reading for this week, for next Tuesday, is I'm going to have you take a quick skim, and I mean a very quick skim through chapter 6 and 7 so that you have a rough idea of what's in there. Don't spend too much time on those. Spend a little more time looking at what metadata is And we're going to get into that ever exciting but very useful topic on Tuesday. Have a great weekend. Thanks.